Good morning to all of you, dear students. We are doing our CCNA-1 Introduction to Networks. We have covered almost all the modules, and today we'll be looking at 15, application layer. Okay. Module 15 is application layer. You have touched upon this in your lecture as well, but in lecture you have gone into details of all the applications and how they work. Now, today we'll be touching a little bit upon some of the applications and protocols that are essential for communication. So these are some of the objectives for today. We'll be looking at application layer, presentation layer, and session layer. Very often these layers are just called one layer, application layer. We'll be looking at the peer-to-peer network. We'll also look at web and email protocols. We will look at IP addressing services, and we will look at file sharing services as well. So let's start with application layer, presentation layer, and session layer. If you look at our OSI model, you can see the top layers are session, presentation, and application. But if you compare it and map it to your TCP/IP model, you'll just see one application layer. Okay. So these application layers and presentation layer and session layer, typically the function is just application layer. Okay. There used to be a very defined border between these layers, but now that border has disappeared. Okay. So we can, even in OSI model, we can, we just call them session, presentation, and application. We call them as application layer. Okay. And the main protocols that are used in these layers are HTTP, FTP, TFTP, IMAP, and DNS. Okay. We'll be studying some of these. If you look at the responsibilities of your presentation and session layer, okay, presentation layer is responsible for formatting and presenting data at the source device into a compatible format, okay, making it into a compatible format. It also is responsible for compressing data in a way that can be decompressed by the destination device. Compressing and decompressing. It also has the function of encrypting data and decrypting data. Below the presentation layer, you've got your session layer, and the session layer, it creates and maintains dialogues between the source and destination application, and it handles the exchange of information to initiate dialogues, keeps them active, and to restart sessions that are disrupted or idle for a long period of time. Now, there used to be a demarcation between these three layers, but now presentation layer, all these functions of presentation and session layer is essentially taken care by application layer. Okay, even in OSI model, okay, we call these three layers just application layer. Okay, so the application layer, after compressing, encrypting, okay, making the application communicate properly with the kernel, with your operating system, it sends the message down to the transport layer. Okay, the two protocols you have at your transport layer, we have already studied TCP and UDP. Okay, and segmentation happens in this layer. From there, it goes down to the network layer. Okay, where we have the IP, logical addresses. Okay, and here the segments are converted into packets. And then from there, it goes to your data link layer. Okay, where you have got the domain of your uh, uh, MAC uh, hardware address. Okay, and here the packets are converted into frames, and then from there it goes to the physical layer where the frames are converted into uh, bits and signals. Okay, and then from there it goes to your destination, and the same process is done but the other way around. Okay, until it reaches the said application. So the reason we have these kind of layers, another important aspect is so that when we program, we develop a software, we know at which layer we have to implement which protocol. Okay, and if you have got some experience in programming, you know, like uh, if you have if you're doing a program in Python or you're developing something in Java, there are certain classes that are pertinent to certain layers of the OSI model and so on. Okay, so that's why layering makes things helpful. So if you look at your application layer, it's very important to know some of the protocols that we have and how they work. Okay, so these protocols are implemented for both the source and the destination. We should remember that. Some of these protocols are the DNS, the domain name system. If we didn't have that protocol, we had to type the IP addresses everywhere. Okay. Uh, for TCP and UDP, uh, the port that they use is 53. The main responsibility of this protocol is to translate domain names such as cisco.com into IP addresses. Okay, we cannot remember all the IP addresses of all the websites in the world, but we can remember their DNS names. We also have the DHCP, Dynamic Host Configuration Protocol, UDP, port 68 for client and 67 for server. It is responsible for assigning IP addresses automatically without us giving a static address. We also have the famous HTTP, which is your Hypertext Transfer Protocol. Okay, that is the reason that we have the internet. Okay, if you go to your website every time, what do you type? You type HTTP. Okay, there. So using HTTP, we go to different websites. Okay. Now your HTTP famously runs on port 80, 8080. Okay. Now let's go to the peer-to-peer networks. Okay. Under that, we have got uh, a client-server model. If you look, the difference from peer-to-peer network and a client-server model, you can see that in the client-server model, there is a pronounced server. The server gives access to the client in the form of a workstation or in the form of a smartphone or in the form of a IP telephone, any kind of device. Okay, that's why it's important for us not to use the word computer. Okay, that can be misleading, because even a smartphone can be considered as perhaps a device or a computer. Okay. I remember I had an argument once with one of my students, and I said you cannot consider it a computer, and then that student told me, "So tell me what you cannot do on a device that you can do on a computer." Okay, I mean, phone that you cannot do that you can do on a computer. So it gets very difficult. Uh, you can list, that time I can list a few things, but as years goes by, it gets more tougher to give an answer to that question, because literally you can do everything on your smartphone that you can do on the computer. You can even, run your packet tracer on your mobile devices. So, so a device is a better name for your clients. Okay. So over here, you can see that no matter whichever client you have, the client accesses the server by using an application. Okay. So this is a client server model. Now, we're here to concentrate on, this topic is peer-to-peer, okay? So in a peer-to-peer, we have got a series of computers. It can be two or more computers connected via a network, okay? Without having a dedicated server. Every device can function as a server or as a client. And a computer can be a server for one transaction and a client for another transaction. Okay. So this is a peer-to-peer network. We can have, and you have built so many peer-to-peer network inside your packet tracer this semester. I mean, you've become experts by now. So even the application, which is developed as a peer-to-peer application, uh, also behaves like both a client and a server within the same communication. Sometimes they use a hybrid system where they can access sort of an index server to get the location of the resource that is on another peer and so on. Now, we have got certain peer-to-peer applications that uh, was programmed early in the 90s, in the mid 90s and all. We had got some applications, peer-to-peer applications that still exist today. Chief among them is BitTorrent, Direct Connect, eDonkey, Freenet, and so on. Now, they allow us to share resources with other computers on the network. Okay. Uh, when you have this kind of technology, okay, uh, you may also have sometimes a server, okay, in the background that actually finds other clients for you. Okay, or even if you don't have that, still the communication happens. Depends what kind of app you're using. Okay, if you have previously downloaded music or movies or intellectual property like books uh, or anything else, you can actually uh, there are so many blueprints of 3D models that you can download and print using your 3D printer. Okay. So everything is out there. All you have to do is go and look for it, look for a torrent of it or a magnet of it. And then, if you have a torrent software like BitTorrent, you can download the world. The whole world is at your fingertips. Okay. You can download tutorials. You can download uh, materials relating to um, any kind of controversial material. People go and download pornography. People go and download uh, um, pirated movies. People, you see, that is an industry which has been created, which is not always positive. Sometimes it's negative. Okay, many people are losing money because of this. Okay, if you want the true answer that when we download illegally by using BitTorrent, are we stealing? The answer is yes, we are stealing. We are stealing intellectual property. Okay, so we have to. There are so many rules. The issue is every time somebody does something about it, somebody stops uh, a torrent sharing website. Okay, uh, immediately another one takes over. Okay, and even we have got a service online that tells you where are all the torrents, and even if they change, they will give you the new address. Okay, because these torrent sites, they keep changing their their location. Okay, and every time they shut down one, another 10 take their place. Okay, so this discussion is that perhaps you cannot stop this. So perhaps people have to come out with alternate ways of making money, uh, rather than just relying on getting uh, their usual way of releasing something and then getting paid over and over again, which was the music industry. In the early days of the music industry, uh, they release an album, and they just once they release it, they get royalties until the end of the life, and that's why we have got musicians who really earn money, and now they cannot do that anymore. They get only limited amount for that. Okay, and you can download. There's so many apps out there that you can download any music. Okay, so the only way they can survive is through their channel on YouTube, or they have to go and make tours. They have to go to different countries, make tours, sell tickets, do a live performance, and make money. Okay, so the world has really changed, my dear students. Even movie stars, they don't earn the way they used to anymore. Okay, to some extent, everything is changing. The world is changing. Entertainment is changing. Our way mode of life and our mode of working is also changing. Okay, look at Netflix, Amazon Prime. Entertainment is changing. How is all this change taking place? Because of internet, because of our application layer of the internet. Okay, so it's very important for us to understand the concept. A few years ago, they were trying to control all this. They were trying to stop it, but then people made noise. Okay, and they said, "Don't do that. Let internet be internet and free." Um, if you look at the internet, one of the major uh, qualities of it is that nobody can control it. Okay, there's no controlling body. Okay, yes, there are certain bodies like ICANN and other bodies that make certain protocols and certain rules, but they don't actually control it. Okay, so that is perhaps a disadvantage as well as uh, an advantage as well. Okay, so that uh, it is free. It's truly, truly free. And depending on the access given by a country, you can do seriously whatever you want. Okay, so um, when we use these softwares, okay, like Freenet, BitTorrent, and so on, uh, we have to be conscious that perhaps what we are doing is not exactly legal. We are feeding on somebody else's intellectual property, uh, I'm downloading an audio book that I am listening privately without paying a single cent. And that person has, perhaps sweated 1 year to write that book, and I don't pay any amount. Okay, that's why some torrents, what they do is they say that, can you give us some donation? Okay, it's like a voluntary basis, but uh, we have to keep that in mind that this is not exactly a legal thing we are doing. Okay, uh, it is not like going to a shop and stealing, but it is stealing all the same. Okay, because you're stealing intellectual property. So keep that in mind. Now, let's go to web and email protocols. Using your HTTP, you surf the net by using this protocol. Without this protocol, there won't be any internet. Okay, so usually what we do is we go and surf the net by first using the protocol name. Protocol is HTTP, and then we type the server name, let's say www.cisco.com, and then we type the uh, file name requested, which is index.html. HTML being the de facto uh, language of the internet. Okay, now usually these days it's not just HTML, it's HTML plus cascading style sheet plus JavaScript. Okay, combination of these make your web pages. So using this HTTP protocol, you can get your web page. Now, when you request your web page, okay, your browser will check with a name server to convert whatever you have typed. Like if you have typed www.cisco.com, it will convert it into an IP address. Okay. Now that IP address, your HTTP will initiate a GET request to the server asking for that index.html file. The server in response will send the HTML code, including the CSS, cascading style sheet, plus the JavaScript, everything, to your client's browser application. And once you get it on your computer, you can open it as your web page. Your browser will open it as a web page, and then you can see. Okay. So the World Wide Web, was an invention by Tim Berners-Lee, and very soon, the moment it came out, uh, it started. The U.S. started implementing it as an e-commerce platform. Okay, uh, specifically by some of the bills introduced by then Vice President Al Gore. They started introducing it as e-commerce platform, and then that's how the internet became much more profound and much more widespread. Okay, and it has come back and surprised us every time. Uh, it first we realized that we can use this as a business platform, and then uh, in the 2000s, the impact of social media was understood, that how you can actually use this to communicate and to bring that college platform experience to the whole world. You can meet people, you can you can share your views, the social media thing. um, and then after that, cryptocurrency, Bitcoin. So this tool that we have, it keeps coming and surprising us over and over and over and over again. Okay, uh, so yes, that's that. Now, if you want a secure connection, you have to use HTTPS rather than HTTP. Okay. If you look at your HTTP, there are three common messages that it has. One is get, the other one is post, the other one is put. So for get, this is a client request for data. That is, a client sends a get message to the web server to request HTML pages. Your post is when you fill up an online form and you click a button, then that form's data will be sent to a relevant location. Okay, that is a web server location. Put is also something like that, but it is used for taking certain files like images and all and sending to a relevant location. Now going to email. Email is something that we have been using ever since the 80s, the advent of the internet. Okay, even if we didn't have the World Wide Web, but the internet has been around since the 60s. Mid to late 60s, we had the internet, and every year it was, more nodes were joining in, and it was getting bigger and bigger until what we have today. Email was a part of it. Very much part of it. Of course, not in this form. The early email was very much character user interface, but most of the protocols that we had in those days, we still have it here. Some of these protocols are the simple mail transfer protocol. Okay, now your SMTP protocol is used to push your email from your device to the server. Okay. On the other hand, the other two protocols, POP and IMAP, is used to pull from the server to your device. Okay. So every time you send an email, you're using the SMTP protocol to push your email to the relevant server, and then from that server to another server. And then using POP3, you can pull the email from your server to your client. It's important to realize that when you're using POP3, you're actually downloading the whole email image from the server. So nothing remains in the server. Okay. So this is the speciality of POP3. Okay. The issue with POP3 is you're downloading the whole image from the server. Okay. Nothing remains on the server. Now, in this day and age, the problem is that we have not just one device, but multiple devices all around the network, and we want access to our email in such a way that it can be on multiple devices. So rather than using POP3, it would be a better option for us to use IMAP. IMAP, what does it do? It keeps a copy on the server. You can download everything on your computer, but you have a copy on your server. So no matter which device, if you use your tablet or your phone, you can still go and you can see your you can still see the same emails on the server. And then if you delete from the server, then it goes off. Okay. So this is the speciality of IMAP. Okay, you have the original messages on the server until manually is deleted. Now let's talk about IP addressing services. Instead of typing IP addresses, what we do is we type a fully qualified domain name, FQDNs, like www.cisco.com or uh, uh, curtin.edu.my and so on. Okay. Now the issue is there should be a server that, translates these FQDNs into a proper IP address. Okay. And that is your DNS server. Okay. So every time what you do is, if you are doing a query from your client, let's say you type www.cisco.com, it goes to a DNS server. That www.cisco.com is translated into 198.133.219.25 if it's IP version 4. And then using that IP address, it will send it to the proper server. Okay, using your HTTP protocol, and it will download it on your client. So your DNS server can store different types of resource records. Okay, these records contain name, address, and type of the record. Okay, now the type of the record, if it is A, that means an end device is IP version 4. If it is NS, that means it is a name server. If consists of quad A, that means it's an IP version 6 address. And if it's MX, that means it's a mail exchange record server. Okay. And that means your email is stored there. Okay. So based on this, actually, you can, you can, uh, you can find out many things. Okay. So your DNS uses the same message format between servers, consisting of a question, answer, authority, and additional information for all types of client queries. Okay. The question would be, for the name server, what is the DNS name server? Okay. Answer would be resource records answering the question, and resource records pointing towards an authority that is, holding uh, the exact IP address related to your FQDNs. Okay. So if you're using a DNS server, something like this. Okay. If, for example, uh, you have a DNS server at the root level domain, okay, and each DNS server maintains a specific database file, okay, and depends on which domain, top level domain you're talking about. Are you .com or .edu like Curtin, or .net, or is it country based? Okay, so it depends on which one you're talking about. So once you go to these domains, and then from these domains, you can go to the subdomains and so on. Okay, for example, if you go to cisco.com, cisco.com has got subdomains, which are uh, subdomains like this. Okay. In fact, let's just try a few things here. Um, Now, getting the getting the exact IP address, all websites don't allow it. Okay, let's try. Let me ping ICANN, the Internet Authority. Um, oh, I'm not sure. Okay, yeah, there. So here I have their IP address. You can see it's a IP version 6. Okay, I can just copy it. Let's paste it in a notepad file temporarily. Okay. Now what I want to do is I want to ping, let's say do they have a version 4 address? Same, version 4. Okay. Yes. Okay. So here, Okay, you can copy this as well. Okay, now using this, let's go and see whether I can open my ICANN page by using my uh, IP version 4 address without using a DNS name. There, it opens my ICANN page. Okay, now this will not work for all the pages, okay, because they have got inbuilt security. Certain pages only it will work, okay. Sometimes getting the IP address itself is challenging, okay. You can also use the ns lookup command. It allows a user to manually query the DNS servers configured on the device to resolve a given host name. This is very interesting because it tells you who is your DNS, what is the address of your DNS server. Okay, so here you see ns lookup. My DNS server is cdn s01 version 6.tm.net.my, and there is the IP address right over there. Can you see? So you can also give the same command and find out who is your DNS server. Okay, so if some of you are living in Senna, then you will see that all our default DNS server will be the same. Okay, or perhaps different. We don't know. Uh, what you do. Mm, yeah. Let's go to, let's say, let me try and set type. Remember, for the mail exchange is MX, if you remember. Okay, set type MX. Uh, doesn't seem to work. Yes, now it works. So particular. Okay, now I want to find out my uh, Cisco, www.cisco.com. Okay. Okay, so it gives you more details about your Cisco and the MX. Does it show you your MX? Not yet. Okay. Okay, there. Here is my responsible mail address. Okay. So you get an idea. Actually, there are so many other commands that you can use to get information about the servers around you. Okay, if you're doing a cybersecurity course, one of the things you will learn that how people can, get access to your servers through some of these commands. Okay, so let's not explore that further. Let's just stop over here. Okay, okay. So that's your ns lookup command. We also have another protocol, which is your dynamic host configuration protocol. Now, this is a very essential protocol to give IP addresses to your computer from a central location, a central server, or a central router. Okay. Um, it would be very difficult, as you know, that to give static IP address to every device in the network. It would be much more easier to actually ensure that every device gets an automatic IP address from a central location, okay, from a Slack or server device. And this is possible for both your IP version 4 and IP version 6. So usually the procedure is that the client will be sending a DHCP discover request. Then the server will give a DHCP offer, and the client will give a DHCP request, which will be followed by the server by giving a DHCP acknowledgement. Okay. If for some reason that IP address is already taken or it's not valid, then the server, instead of giving a DHCP acknowledgement, it will give a DHCP NAC, that negative acknowledgement. Okay, it won't give that IP address. So after that, again, the client has to start with DHCP discover, looking for another IP address. Okay, so this is how it works. Now, another important feature of our application layer is file sharing. If you're doing file sharing, you have to understand the concept of your FTP protocol, okay? So that you can, transfer files from one location to another location. First, what you do is from your client, you access a server and establish a connection using port number 21. Okay. And then you establish another connection on port 20 for the actual data transfer. Okay. And then the data transfer can happen in either direction. The client can download it, which is going to pull data from the server, or you can push it to the server. Okay. If you're doing a pull action, that means you're getting it from the server. Push means you're uploading it to the server. We also have, besides FTP, we also have a server message block. Now, this is a little bit different, whereby the connection, okay, is a long term. You first send an SMB request to the server, and the server gives you a SMB response. Okay, you have to first, start giving the request. The server will authenticate you and give you the response and allow you to access the resources on the server. And this is not a short connection. This is a long-term connection, and you can, share files and do whatever you want. And once you're finished, it will terminate that connection. Okay. So that brings us to the end of our application layer. Does anyone have any questions? Okay, yeah, it's very straightforward and, nothing difficult over here.